Okay, so this is what every web developer should know about database optimization. So if you're not here for that, I'm sure there's room in 228 for the Microsoft desk. All right. So this room is really big enough that it probably should have a PA system, but hopefully, can everyone hear me fine? If I start getting too quiet, just tell me to speak up louder. Just a little bit about me real quick. I've worked at Omniture, Spark Networks. You probably haven't heard of Spark Networks. They do sites like LDS Singles, LDS Weagle, JDate, which is the biggest one and most expensive. CrimeReports.com. And then for the last year, I've been just doing stuff, just consulting and have my own business. So we're going to talk about what slows down your web page. There's a couple things that are common things that slow down your web page. One of them is content load time. CSS, JavaScript, images, Flash, whatever. We're not going to talk about that today because we're talking about database optimization. There are some other talks that talk about that. Another one is poorly optimized code. I've seen this, as far as a website that was really slowed down by poorly optimized code, I've seen it happen 3 times. So, usually it's not the code itself that's a problem. Let me see, at least 2 of the times involved regular expressions. So, way too many of them. So, I'm trying to think, the other one was with creating objects all the time. She created about 100,000 objects every time you loaded a web page, and that took a while, I guess. I think that was in PHP 3 as well. So the last one, the one that almost all the time, if you've got a slow website, besides the content load time, the other thing that's almost always the case for a slow website is that your database queries are going too slow, and that's where you're going to run into trouble. So that's what we're going to talk about here. Okay, so we're going to talk about a few different problem cases of where you could be having database issues. So the first one of the most common causes is going to be poorly indexed queries. Now, every web developer should know that you want to put indexes on your database. That's all well and good, but do you know where to put them and that kind of thing? So sometimes you have a problem with too few indexes. I've also seen problems with too many indexes, which can be a problem. What happens if you have too many indexes is every time you write to your table, it has to write all of the indexes as well. It has to readjust them. And so every single write to that table, every time you add an index, that's adding one more write that it has to do, physical write to the disk. So having too many indexes is a problem as well. And this kind of goes along with too many indexes. I've seen a lot of cases where there are redundant indexes. So you index one thing and it's basically indexed already over here, and you're adding to your write time and you're not getting any performance on your select time. So possible solutions to poorly indexed queries. First, you want to understand indexing. So the order of the fields in an index matters. So if you have an index across multiple columns, then what you're going to have is you have to start with so the leftmost column in your index needs to be the thing you're going to be. You can use just that part of the index, and for example, this is what I was talking about redundant indexes. So you had an index over columns A, B, and C. Now, if you're looking up something just on column A, it can use that index because that's the leftmost part of that index because it's A, B, and C. So if you just tell it A, it'll still use that index. If you just tell it B, it will not use that index. because it needs A before it can look up B. So it's just kind of a, I mean, you think of alphabetical order, you know, if you know someone's last name, you can look them up in the phone book. If you know the first letter of their last name, you can, you know, find that quickly. If you're looking up by the second letter of their last name, it's not going to help you very much. You pretty much have to look through the entire phone book, right? So that's kind of where, as far as leftmost parts of indexes and ordering. Indexes are not always used. If you're indexing, another case I've seen, they had latitude and longitude indexed. So they had it was across 2 columns, latitude and longitude. And what they were doing was they were giving a range for each of them. They were trying to look up everybody within a certain block, a certain area. And so they would say, okay, well, the latitude is between this and this, and then the longitude is between this and this. It can only use the latitude for that index. Once you do a range, it can no longer use the rest of your index. Does that make sense? Because once you're in, if you specify the leftmost part of the index, then it can move on to the next one. But if you give a range, it cannot. So you have to think about that. And there are ways around that. But that's one of those things to be aware of as far as whether your index is actually going to be useful. Indexing wheres and joins. So if you're in MySQL, which I do most of my stuff with, the explain statement. Does everyone know about the explain statement? You just explain and then you give it your query, and it tells you what it would do. It tells you what index it'll use, and how. And you look at the cardinality. That tells you how many rows it's going to be coming out of that index. You want to get that as low as possible. 1 is great. That means you're doing a single row lookup. If you get thousands of rows in your cardinality, then that's how many it's going to be looking up. So you want to use the indexes to filter down as much as possible, especially if you're doing joins. You want to get the first table in your join down as far as possible before it has to join onto the next table. So you're looking up fewer rows in the next table. Because the next table it's got to look up 1 by 1 for each of those rows. So you give it, you're looking up by ID, the primary key probably on the second table. And so it's going to have to, it's just got a bunch of IDs and it's going to go look them up. And so you've got to know, you've got to narrow that down as much as possible. And so changing around the order of your join can sometimes work. Sometimes it doesn't. Sometimes you have to do it in a certain order. But a lot of times, and if you're using MySQL, sometimes it'll change it for you. If it knows that, based on your query, if it knows that it can change it around safely, it'll change it to make better use of your index. So it knows that, the table you've got second actually has a better index, and so it'll use that one first. So you're going to want to make sure your where clause has, is limiting that first table. And then you're looking at the joins. How are they joining together? Hopefully, anything after the first table is joining on a primary key. If not, that's not going to. If it's not a primary key or a unique key, then it's going to be a little bit slower. And you could end up with multiple. If it's not a unique key, then you could end up with multiple rows. Expanding out your result set with multiple rows, and that's something you just need to be aware of. Sometimes you're doing that on purpose, and that's good. So, what you're looking at, like I said, the filters on each table are going to be what are you doing as you're narrowing it down, or as you're joining. You want to be narrowing down your result set as much as possible before the next row. Sometimes you got something with 5 joins. It's not pretty, but sometimes you got to do it. And you just want to make sure that you're keeping that, how many rows it's having to look up as small as possible. Another thing you can do is different kinds of indexing. Full text indexes. Now, if you're using MySQL, it has built-in full text indexes on the MyISM table type. For one thing, you shouldn't really be using MyISM. And for another thing, their full text indexes suck. So, what?
You shouldn't be using MySQL. I mean, I realize.
Okay, there are certain cases where it makes sense if you don't care about your data. Then you can use MySQL. Otherwise, you should be using InnoDB. I use MySQL for caching tables. So I'll take something, so I have everything in an InnoDB table, and then I'll cache it, I'll cache like a subset of it into a MySQL table, recent things or something. So I run, my personal business, I run a message board. And so most people are looking up recent messages. And so I have all the recent stuff in a cache table. That's MySQL. The stuff I care about that can't be rebuilt is in InnoDB. So that's my only qualifier on when you should use MySQL. So there are alternatives for full text indexing. You generally are going to have to look outside of your database engine. There are specific search engines that you can use that do full text indexing. I use Sphinx. Sphinx is really nice if you're a MySQL user because they actually have a way that you can plug Sphinx in as a, they have a Sphinx storage engine, so you can actually directly access your Sphinx data from, and you can join against it and stuff like that, which is convenient. There are some other ones. Yeah, there's a ton of them. Apache's got one. What's it called? Solar. Yeah. Solar. Is that the same thing?
It uses the same backend.
Okay. Yeah. There's some other ones too. I can't remember them off the top of my head, but there's stuff out there you can use. If you want to do full text stuff, definitely look into the different solutions and see what's best for you. It might depend on your data set. So, geometric indexes. In MySQL, and I think Postgres has it as well, you can do geometric indexes. So those are where you actually have shapes in your database. They can be, I can't remember if they can, I think they're two-dimensional. But you can do shapes, and then you can say, you can give them a custom shape and say, I want all the points, in this table that are within this shape, and it'll find them all. This is something I used at my last company, Crime Reports. I was at, they would have, work with police agencies. They would set up beats, and they wanted to know what crimes happened in a certain beat. And so these are irregular shapes on a map. And so we had all the crimes mapped out. Those were all in the database. So we just joined that against the shape and used a geometric index. One thing to know with MySQL, if you're using MySQL, the geometric indexes or the geometric functions are broken. So if you ask, you have a shape like this, when you use the geometric functions in MySQL, it uses the minimum bounding rectangle for that shape. And it'll give you everything. Now, if you attend my talk later today, I have another one about MySQL forks, all the different alternative MySQLs. There's actually one called MariaDB. It's written by the guy who originally wrote MySQL. He left when they got bought by his son. It became more mobile when they got bought by Oracle. But so he's kind of forked MySQL and is doing some stuff. They fixed it. So if you use theirs, it's a drop-in replacement for MySQL. Just throw in MariaDB, and they fixed that problem. So their geometric functions actually work. As far as I know, MySQL still hasn't fixed it. I haven't tried it in 5.5 or 5.6, but as far as I know, it's still not fixed. Okay, next problem, suboptimal queries. Full table scans. Does everyone know what a full table scan is? that's when you don't have an index. Or you can't, it's not using your index for whatever reason. This is something where explain is helpful. It'll tell you when it's doing the full table scan. So use explain, it tells you, but that means you're not indexed. Either your index for some reason can't be used, or you don't have an index at all for it to use. So a full table scan, what it'll do, now there's some cases where it's actually useful to do a full table scan. For example, if you have an index on a column, like that's basically a Boolean, you know, 0 or 1, right? If you have an index on that, MySQL will almost never use that. Because it's practically useless. If it's using the index, it's having to do lots of random access reads on the disk. It's faster to do sequential and just read the whole table. So, binary or Boolean indexes, not very useful, unless they're part of a larger index. So a full table scan is any time you have to read the whole table. If it's a short table, maybe that's not such a big problem. But if it's a larger table, and you're really the problem is when you're not asking for the whole table. You know, sometimes you just want everything out of the whole table for some reason. If that happens, well, obviously you need to do a full table scan. Other than that, you want to try to keep that row count down as low as possible, because everything it looks up on disk is going to cost time. Anything it can basically cut out and say, I really don't need to look at this whole section of the database, that's going to reduce your query time more than anything else. Large joins, if you're joining and you have too many stuff on the left and it's kind of carrying over, that's going to cause you problems. Or I guess the other large join is when you accidentally do a Cartesian join. So that's who's accidentally done a Cartesian join, where you forget to put a join clause and it's just multiplying it. Yeah, I had someone do that. He thought he was unioning, I think, but he did it across 20 tables that had on the order of a few 100,000 rows each. So he couldn't figure out why it never came back. So that's a very large join. No one ever does Cartesian joins on purpose, though, right? Impossible to index. Sometimes you have data that just you can't index. When I worked at Spark Networks, the dating sites, one of the things they did was they had, everyone came, you put in your profile, all this information about you, and then when you're searching for random bits of data. I want to search on this and this and this. I care about eye color and hair and where they live. So you have all these bits of data that you're searching on. It's very difficult to index that well. And so sometimes you just throw a bunch of indexes on and hope something sticks. There are ways to do that. There are database engines that are good at that, but the default ones you can deal with in most databases do not deal with that one.
I've had good success with MySQL with that type of data by pulling ORMs. And by doing that, MySQL starts to pick all the different indexes and index for each attribute.
Right. Yeah, and it depends on your data. Because sometimes you have data that will work with that. Sometimes you don't. And that's kind of the issue. You kind of, if you want hair color and eye color, and you've got it, it's kind of, you have to kind of know ahead of time what to index in order to make it work.
You just index each attribute to it. Or you put each attribute to another table.
Oh, right.
And then join each of those. As you needed another attribute, you join the table appropriately.
That's true.
And then it picks up the index and does very well.
Okay. But then you have to, when you want the users, and you have to join across the tables to get the ones. It can get really pairing. So. Okay, so solutions to your suboptimal queries. Like we talked about, ensure your where is filtered properly. You're using indexes. Understand joins. There's a lot of developers who have a passing knowledge of SQL and really don't know how to join properly. Understanding joins will make a huge difference in your in understanding how to optimize your SQL. That's probably more than anything else. If you can get joins nailed, you'll be able to write much more optimal queries. Understanding the join order, like we talked about, how the indexes are used, and getting the filtering happening in the right order. Understanding all that, and part of that is also understanding your data. You have to understand your data in order to understand how to craft your queries. And then the other solution that sometimes helps for suboptimal queries is just to cache the heck out of it. Sometimes there's nothing you can do, it's just a bad query and it's going to take 5 minutes to run. I've had that happen, so you run it, hopefully, if you ever have that happen, you don't need it very often, or you can have it, you don't care if it's a little behind. I had that, we had some companies who've done that where, they have reports that run every day. And these reports just take a while. They're getting all sorts of information. So we run them once a day at like 2 in the morning. And just put everything in a report table or something, put all that data there. And that way when people are viewing the report, it's very quick. Because what we care about is user responsiveness generally. The query might take 5 minutes to run, but as long as the user doesn't see that 5 minutes, you're usually okay. So if you can find a way to make that happen sometime else, when they're not going to run into it, that'll help you. Too many queries. This happens when you do queries inside a loop. Sometimes it starts out being a good idea, and then as your site grows, all of a sudden it's no longer a good idea. Redundant queries. You keep on getting the same information from the database. We've seen that a lot. And unused information. You get information and then never use it. If you do a select star, you're getting unused information. That's not as bad as getting, just doing whole queries that you don't use any information. But it's still the same Rails. And that's basically, we'll talk about that in a minute. That's my next one. Your ORM hates you. So your solutions to too many queries, get it all at once. If you want a whole bunch of information from one table, instead of looping and selecting each one at a time, get it all at once. Better yet, you probably got the list of what you needed from the previous query, join it. Get it all at once. It's much less expensive to do it that way, rather than looping and doing multiple queries. So just get it all at once and then loop through the results instead of looping through the queries. Eliminate the redundancies. Sometimes there's information that you get, for example, from a user table. You might get some information, and that information is good for the rest of the session. Put it in your session. Don't keep on getting it every page. Some information you can just do that, store it away. You have to make sure, if you're going to cache information, either in a session or in another table or something like that, you have to make sure that your code is smart enough to invalidate the cache if something changes, or if it's important. Sometimes it's not important to know that it changed, and that's even better. But you do want to know, like if you get their user information and store it all in their session, if they go to their profile page and edit their profile, or edit their account information, then you need to be smart enough to fix their session, re-get that information, or just put it in as you're storing it in the database, also update their session to have the correct information. And that kind of goes along with cache and gather. That's a solution for lots of things. If you're doing stuff, so make sure it's only done once. Make sure you have an expiration on stuff that you cache. You don't want to cache forever. because sometimes stuff changes and you don't do a good job of invalidating, or some, heaven forbid this would ever happen, some developer goes up in and changes stuff in the database directly. I know this never happens at any real companies, but... Okay, so the next problem is your ORM hates you. Who uses an ORM? Lots of people use ORMs. They hate you. They hate you. They want your site to fail. Okay, ORMs. Hopefully, this one has gotten a lot better on caching. Most ORMs do a good job of caching. At least if you set them up properly. You know, they'll put stuff in memcache. They do a good job of invalidating stuff. As long as you don't go do stuff on your own. As long as you just use an ORM, it'll know everything.
I don't know what an ORM is.
Object relation model. So that's where you have an object. You basically have a class that relates directly to a table in your database. And so when you create an object with a specific ID, and when you make changes to that object, it takes care of updating the database for you. Now, one of the things that is prone to happen with ORMs, like I said, hopefully they are caching. They do actually, like I know Rails will, if you go and get the same information again in that same thing, it'll say, oh, I've already got that. So it is smart about that. It will try to get things 10 times, but it'll at least be smart enough not to actually do it. ORMs tend to make a lot of queries. They're going to, it's very easy to do stuff in a loop with an ORM. It'll, without thinking, yeah. You just load a bunch of information in a loop. It's very easy to do. They tend to make it very easy to do way too many queries. It's astounding when you look at how many queries are happening sometimes. A lot of times, it depends on how you set up your ORM, but it may not know enough about your database to do things, and a lot of times, very, very few times anyway, I've seen it set up really properly where it can figure out how to do joins for you and do them very well. So that's a big issue because joins are a huge part of being able to get more information all at once. The other thing is that a lot of times ORMs just load everything, and they don't need most of it. So there's lots of information. They'll just load the whole, the whole database every time you load a page. It doesn't need all that. So the solutions: get to know your ORM. If you're using MySQL, there is a tool called the Percona Toolkit. It used to be called MattKit. You've heard of that, M-A-A-T-K-I-T. It's renamed to Percona Toolkit. It's just useful utilities if you administer MySQL. All sorts of stuff. This one is PT Query Digest. What it does, it has different ways of getting at the information. The way I like to use it is actually I'll do a TCP dump of all the MySQL traffic going from a certain server, and then I'll take that dump and run it through PT Query Digest, and it will go through and analyze. It knows the MySQL protocol. It'll analyze all that information, pull out all the queries, how long they took, that kind of thing, group them by similar queries, and tell you which ones are taking the longest. And it's very, very useful information. And it has all sorts of different ways of doing this. So you can get all sorts of information out of that.
So what's the difference between that and like the slow query log?
Well, it gets everything. It tells you everything, and it'll associate them by session. For example, so you can say for this session, these are all the queries that happened. Things like that. You can get all sorts of different kinds of information from it. And it'll also, like I said, it'll find similar queries and group them together and say, you ran this type of query 200 times, and it averaged this long.
Yeah, I just want to say, I know some ORMs will give you some pretty nice analytics on your queries. They'll tell you, how long they took, the stack traces to where in your code they took place and everything. So they can be used.
Now, if you're using any kind of wrapper around your any kind of database abstraction wrapper. Then the poor man's way of doing this is just to put all the queries you do in an array and then register a shutdown function, like in PHP, for example. You can do this in other languages too, but just say, at the end of my script, I want to just spit out all the queries that happened and how long they took. So you can see that on a per page basis very easily. At a previous company, a guy put that into our code, and he had it set up so that he would just have to put a cookie in his session, or a cookie in his for that domain, and then on every page it would just list those at the bottom.
Are you aware of anything like this for Postgres?
I'm not. I'm not as familiar with tools for Postgres. So I don't know as much. I know how Percona does a lot of stuff. If you want to really get to understand what's happening in your database, you should probably at least switch from MySQL to Percona Server. It's a drop-in replacement, and they just have tons of more information. When you're looking at like show process list, I believe, I'm 99% positive they have. I know MariaDB has it, but I believe that Percona has it, where you, like, if you alter a table in MySQL, you know how you have no idea how long it's going to take. A couple hours later, you're wondering, well, when's this going to finish? If you're using Percona, I believe if you do a show process list, it'll give you a percentage. So it's nice. Another thing that's nice to know, if you use the Percona toolkit, they've got another one in there called PT Online Schema Change. It lets you alter a table without any. So what it does is it creates a new table and copies all the information into it, puts a trigger on it on the old one to make sure that any changes to it get put into the new one. And so it does all this, so you're still using the old one. And then when it's done, it renames it in place atomically. And so you can do your alter table with no downtime, which is a wonderful thing.
Using Facebook method. Was it using the online schema replacement that Facebook developed?
It's possible. They've had theirs for a long time. So
Facebook's on it for years.
yeah, I don't know. It's probably the same thing. It's just they've got a bunch of tools. There's some other tools they have in there that they'll, for replication, they'll check. They'll do table checksum and stuff that'll make sure that your replication tables, and it'll tell you which rows are out of sync and stuff like that. If you get replication problems. If you get replication problems, you're probably using MySQL. Just saying. But they've got stuff, and it uses that same algorithm that they use for determining whether the replication's out of sync to make sure that copies over the table in chunks and make sure it's not locking it up for very long and all sorts of stuff. So, tame your ORM. There are things that you do. Most ORMs at least have ways to tell them, no, I really want to do this my own way. And so you can tell them, you can tell them to do a join and how to do the join. You can tell them to, I want to get 10 rows out of this table. Instead of moving through and getting them one at a time, you can get all 10 at once. I can't speak to your specific ORM, but most of them do have ways to do that. So you should learn and use those methods. And in some cases, your ORM still hates you, and it's best just to tell it what your SQL is and tell it to run it. And most of them do have ways to actually do that, still using the ORM ostensibly, but you're just telling it exactly what to run. Okay. The next one, too many writes. Who's had a problem with, you just have tons of writes to your database? You got that? There are lots of cases where this can happen. For example, in a lot of cases, it's desirable. You want, if you want to make good business decisions, you need to have as much information as possible. And so, gathering statistics, for recording stuff is good. Making sure you're keeping track of everything that's happening. Those kinds of things are good. When I worked at this dating site, they wanted to know whenever anyone looked at someone else's profile and who's looking at whom and what they clicked on, and store all that in the database so we could tell everyone, you had 30 people look at your profile today, and you can look at who had looked at you and all sorts of stalker stuff. So we were writing stuff all the time. Now that could be expensive. Every time you write to your table, it has to update every index on that table. So that can get expensive real quick if you're doing thousands and thousands of writes a second. So that's a problem. Sometimes it's not that you're doing lots of little writes, it's you're doing big writes. You're just updating the whole table all at once. For whatever reason, there are lots of reasons you might have to do that. But that can be a problem. You're basically tying up the whole table, whether it locks up or not, it's still using a lot of resources, making things slow, based on those. So what can you do about that? The first thing is, you shouldn't be using MyISO, especially if you're doing lots of writes. Everyone knows what MyISO does with locking, right? Table locks. If you want to write to anything in the table, the whole table is locked until you're done. Only one write can happen at a time. It's very inefficient as far as databases go. Use InnoDB. It allows concurrent writes. It's a wonderful thing. That's what all the Postgres users have been mocking MySQL for all those many years. So we finally got InnoDB. That's what they were mocking us about. And we mocked them back because they had it back in the database every night. It went both ways. But InnoDB, you should be using it. It's going to allow you to do multiple stuff concurrently. Use something, it's what databases, pretty much every database out there uses, called multi-version concurrency control. But it's basically a way to have multiple things going on at the same time with your database. So you don't have the table lock problem, except in certain cases where you really are writing to the whole table. In that case, you're pretty much going to lock up the table. You do have the deadlock problem. Since you're doing more than one thing at once, you can have a problem where you're trying to write to one thing that was being selected here and used somewhere else, and you just throw it in the middle of it, and now you've got a circular race condition. It will detect it if it's sitting around waiting. What it basically does is it says, I'm going to time out after so many seconds. If I'm still waiting for one of these locks to be released, then I'm just going to give up and say, I found a deadlock, I can't write. And so deadlocks are possible. You have to be aware of them in your code and make sure that you deal with them properly. But for the most case, it's only in very specific cases that you'll run into that problem. In most cases, you won't. Where you're going to run into that problem is generally where you have transactions, so you're doing multiple queries in a single transaction, and those can run into those circular problems. Batch your writes. This is a wonderful use for MyISO tables. Write all your data to a MyISO table, and then throw it in your real InnoDB table all at once. Now you have to, with that, the one caveat is you don't care about your data. Remember? It's in MyISO and you don't care about it. So if it's okay if you lose a couple minutes worth of data, then store it all somewhere, put it in Memcache, put it somewhere else. Just put it somewhere, and then all at once, dump it all in. And there are easy ways to set that up that'll be a lot faster. But it has to be data that's not that critical. It doesn't matter that it doesn't get in right away. And if something happened to that server and you lost that, a couple minutes worth of information, that wouldn't be a big deal. Don't put your transactional information in there. If you're doing billing stuff, you're taking someone's credit card, don't do this method. that information you want in your database right away. But if it's not critical, if it's just like the last time they logged in and you really, it's not the end of the world if you forgot when they last logged in, that's fine.
What about instead of doing ISAM using a memory?
In memory tables?
Is that okay, or? is
That's
that
fine.
faster or slower?
You have to be aware of the limitations of the memory tables. So,
Out of curiosity, what is it about my ISIN that makes it so volatile?
it's not crash safe. If your server crashes, your data is probably hosed. To varying degrees, maybe a few rows, maybe. There are times you go and you can run the repair table command that'll try to fix it, and it'll say, "Oh, I found 600,000 extra rows and deleting." Oh, whoops. Sorry. Hopefully you have backups. That's just how it goes. So, yeah. So anything you can do to kind of batch those into a single transaction, that you can update a whole bunch of rows all at once. MySQL has some great tools for batch loading data, even doing batch updates. You can batch update, like even just specifying stuff. Well, you can load tons of data and or update it at the same time using the on-duplicate key. Which will tell it if it's trying to load the row and it finds a duplicate key, just update it instead. And you specify what to update. So you can give it 1,000 rows at a time, just load them all. It'll update the ones that need to be updated, insert ones that aren't there, that kind of thing. So there are wonderful things you can do to just do that all at once. Handler socket. This is something, again, if you're using the MySQL that you got from Oracle, you don't have this. If you're using anyone else's MySQL, then you should have that. Handler socket is basically a NoSQL interface to your InnoDB tables. So you can go and just using a NoSQL interface, you can get, they have libraries for most of the major languages. All the ones that I know of. I think they have pretty much all of them, but what it'll do, you just tell it, update this particular row, insert this row, delete this row, that kind of thing. And it's just what's simple. It's only operating on single rows at a time. But what it does, again, like I said, you have to be aware of what it's doing under the covers because that's not going to be the best situation or the best thing to use for critical data. What it's doing is kind of the same thing I talked about with batching. It's taking all those in and putting them into, it'll take everything over, a tenth of a second or something, and it'll pull it all into a single transaction and then write it and commit it, and it'll all get written at once. The advantage of that is you're only updating your indexes one time. Instead of 1,000 times per 1,000 rows, you're just updating your index once. So that's why you want to use something that batches those. Handler socket does that. It's a lot faster. It actually, in some tests that they did with it, it was developed by a gaming company in Japan called DNA. They developed it, and they actually got better performance out of it than using Memcache. So it's faster. They got more queries per second putting data into it than using Memcache. Very fast. So they were doing that a ton. It was some kind of online game, and so it was constantly updating statistics and stuff like that. So they got very good performance out of that. The nice thing about that is that if you're using Memcache, then Memcache is a copy of your data. And you've got to make sure that you're invalidating bad stuff in the cache and your expiring stuff, you're keeping stuff up to date. With Handler socket, you're treating it like Memcache or something else, some other NoSQL solution, but you're really updating your InnoDB table directly. And so you don't have to worry about your data getting outdated. Because you're all good. Okay. Replicate. Most databases support this. If you're using SQLite, I'm sorry. doesn't support it. But pretty much everybody else, I don't know about Access, they probably don't. Everybody else supports replication. It's not a cure-all. It doesn't fix all your problems. You hear that a lot of times. Oh, you're having problems? Too much load to replicate your data. It doesn't fix everything. You need to understand how replication works and what are the trade-offs. It's going to be all the writes that are happening on your master are still going to have to happen on the slave. So if you're really write-heavy, it's really not buying you that much. In fact, it might be slower because on the slave, it does them one by one. It's doing them in order as they're committed. Whereas on the master, it's doing them, you have multiple things able to happen at once. On the slave, it's doing them in commit order. And so it's not a cure-all, but it does, if you have a very read-heavy environment, then it can spread the load. It does spread read load very well. It's also very useful for doing backups, or doing those really big report jobs that you have that are going to take 5 or 10 minutes or sometimes hours to run. Run them there. Run them somewhere where it's not going to affect customers. Just get that data somewhere else where you can run that kind of thing. Run a full backup of your database and not have to take anything offline for your customers. Okay. So in conclusion, you need to know what your database is doing. You need to know what your code's doing as far as how it's communicating with the database. There's lots of tools out there. There's there's ORMs, debuggers you can use as well. If you want to just throw some debug code in your SQL wrappers. But use those, find out what's really happening. And then figure out, what are my bottlenecks? Fix one problem at a time. Look at, what's the biggest problem we've got right now? Once you understand what's happening, then you should be identified what's your biggest problem. And fix it. And then go on to the next one. Don't try to solve everything at once, but solve it one at a time. Make sure you understand the ramifications of your solutions. Like I said, a lot of these I had qualifiers. They're not always the best solution for a specific problem. You need to understand what are the potential problems you're going to run into. I've heard people talk about, one of the great solutions will do circular replication. Then everybody's master. You can write to anything. Yeah, there's all sorts of problems with that. You got to know what you're doing. It does work for some people, but it doesn't work for a lot of people. You really have to be careful in your code to really understand. You have to understand your database and how it's, how it can, how what you're doing is affecting how everything fits together. All right. Are there any questions? So I'm done.